Hello everyone. Okay, chapter 2 is about engine operations. In this lecture, okay, we're gonna talk about how the engine is operate, okay, how it works, right? Okay, so let's start. Let's get started. Okay, so when we say engine, okay, engine is an equipment or a machine, okay, that convert chemical energy in the fuel into mechanical energy. So first we have chemical energy inside the fuel, right, which is basically hydrocarbon, and then we convert it into mechanical energy, which means the shaft turning. Okay, a shaft is turning. The energy is released from the fuel in the form of heat when the fuel is burned in the cylinder. Okay, there are basically two types of internal combustion engine. Okay, the most familiar one is reciprocating, which means the movement of the engine is up and down. Okay, and rotary, which is the basic movement of the engine is rotary. Okay, most of the automotive engine are reciprocating, which means that we have piston inside and piston move up and down. Okay, the rotary engine, instead of a pistons, it had rotors. Okay, rotors rotating inside a housing. Okay, we're gonna talk about that. Okay, let's focus on the piston engine. Okay, there are two types of piston engines. The first one is spark ignition engine, or we use SI engine, okay, for spark ignition engine. Okay, as the name says, we ignite the combustions. Okay, we start the combustion by ignitions. Okay, the other one is compressed ignitions engine. Okay, so we start ignition by compressions. Okay, this one create ignition by spark. Sorry, create by spark. This one create ignition by compressions. Okay, this one is this CI engine use diesel fuel. Okay, this SI engine use gasoline or petrol or benzene fuel. Okay, the three differences are the type of fuel use. Okay, if you use for SI engine, you use gasoline, or in some country they call it petrol. Okay, gasoline is US word for benzene in Thailand. Okay, but some country, the British English, okay, they use petrol. Okay, petrol for benzene. Okay, this fuel is basically highly volatile. It means that it's vaporized very easy. It's vaporized very quickly. For CI engine, okay, we use diesel fuel. Diesel is quite different from gasoline. Okay, it has higher number of carbon than gasoline. Therefore, it's more thicker. Okay, it does not vaporize very quick. Okay, so that's diesel fuel. Okay, the second difference is the way the fuel gets into the cylinder. Okay, for SI engine, the fuel vapor mixed with air before. Okay, so it's mixed before of air before it gets into the cylinder, and then the spark come later. Okay, but for CI engine, okay, fuel mixed with air in the cylinder. It's a little bit different. So for CI engine, okay, normally when we compress, okay, we intake and we compress. During intake and compress, we only have air inside. We don't have fuel, just air. But we compress a lot, okay, such that the air inside the compression chamber is very hot. Okay, I have high pressure and high temperatures. And then after that, we inject diesel into the cylinder. So the fuel mixed with air in the cylinder. Okay, after the compression stroke. Okay, the third difference is the way fuel is ignited. Okay, for SI engine, the ignition come from the heat from the electric spark. Right, the spark from electricity. For CI engine, we use heat of compressions, which means we use the heat of the compressed air. Okay, the heat that the high temperature compressed air. Okay, we use that heat to ignite diesel. Okay, we can do that because diesel can ignite at lower temperature than benzene or gasoline. So this heat of compression or the temperature inside the combustion chamber is enough to ignite diesel, but it's not enough to ignite benzene. So we have to use spark because spark has high temperatures. Okay, so those are the difference. Okay, those are the two types of engines that we use nowadays. Okay, most of them. Okay, so this is a picture of spark ignition engine. Okay, we're gonna focus on spark ignition engine. Diesel engine, engines are very similar to gasoline engine, SI engine. So what we have here, engine is basically separated into two parts. Okay, and the divider is this line. Okay, okay, and probably this line. So engine has main part. So we call it engine block. This is where the piston move up and down. We have cylinder, we have piston and everything, right? So this is the main part. And this is top part of the engine. Okay, we sometimes we call it engine head. Okay, engine block and engine head. Okay, on the engine head we have valves and we have valve train mechanisms. Okay, the mechanism that control the valve. Okay, those are on the engine head. The piston and cylinder are in engine block. Okay, and then under there is the oil pan. Okay, where we have the lubricating oil. Okay, so basically we have two parts. Okay, and the engine block part looks like this. Okay, for four-cylinder engines, you have cylinder, okay, which is the basic the hollow core inside. Okay, and you have pistons installed inside the cylinder because it has to move inside the cylinder, right? So it's different part there. Okay, and piston connect to the connecting rod and connect to crankshaft. This is a picture of a crankshaft. On top there, a cylinder head, okay, is a block, okay, like a solid block with these valve trains inside the block. Okay, and then we have valve cover on the top. Okay, so that's the how engines look like. Okay, now for spark ignition engines, okay, you have piston moving between top dead center and bottom dead center. Okay, one way from TDC to BDC is called stroke. Okay, go from BDC to TDC is another stroke. So we call piston stroke is the distance between the movement between top and bottom. Okay, now when we compress air fuel mixture or compress air, if we have like a hot compressed fuel and air, okay, it can combust and then it push down the piston and we get power. So now because the piston has to move inside the cylinder, okay, it has to be smaller than the cylinder. So normally the diameter of piston is smaller than the diameter of the cylinders. Okay, so there's a gap. Okay, there's a clearance or gap between the piston and the cylinder wall. Okay, this is the cylinder wall. Okay, and the piston move up and down. Okay, normally this cylinder walls, the gap is called piston clearance. Okay, piston clearance, if it's too much, okay, the gas, your fuel and air or your exhaust gas, can leak through this. Okay, through this clearance. Okay, we call that leak, blow by. Okay, this is the word for it, blow by. Okay, now to prevent blow by, okay, the piston rings, okay, this is our piston rings, are installed on the piston. Okay, you see all this groove. This is the first groove, the second groove, the third groove. Okay, in this groove, we're gonna install the piston rings. Okay, and piston ring gonna seal the combustion chamber. Okay, we have two type of piston rings. The first one is is called compression ring, compression pis, compression rings. Okay, the function of it is sealed between the piston and cylinder wall. The other one is oil control ring. Okay, basically it scrape off the lubricating oil on the cylinder wall. Okay, which means that there is lubricating oil on the cylinder wall. Of course, piston move up and down in the cylinder. Okay, there has to be metal to metal contact, so we want to prevent that. Therefore, we have to put lubricating oil there, and we don't want lubricating oil to go up into the combustion chamber because it's not fuel, right? If you burn the lubricating oil, you get smoke, right? Some energy, but mostly smoke, right? Therefore, we need this oil control ring, looks like this, to scrape the oil and the oil go down into the oil pan. Okay, now this piston has to move very fast, right? It's move up and down all the time, and the engine RPM is, I don't know, 3000 RPM, right? So it goes up and down very fast. Therefore, we want it to have small weight, okay, or very less weight, okay, such that it has less inertia and so that it moves fast. Okay, that's why the piston is normally made of aluminum alloy, not steel. Steel is heavy. Okay, it is made of aluminum alloy. Okay. Normally, we use a process called casting of the melted aluminum to create pistons. Now, in order to convert, okay, the reciprocating motion of the piston up and down into rotary, so piston will have to install with the piston pin. Okay, this piston pin gonna go into this piston pin hole. Okay, the hole for piston pin, which means that the piston is up here. Okay, the pin is there, so piston can rock left and right or rock like forward and backward. Okay, this piston pin then connect to the connecting rod. Okay, so we use this connecting rod and crankshaft, okay, and piston pin, okay, these combinations, okay, to change reciprocating motion, okay, into rotary motions of the crankshaft. Okay, this crankshaft is the main shaft of the engine. Okay, so we install piston pin there, connecting rod there, so connecting rod can rock back and forth, okay, of the piston. Then the connecting rod connect to the crank part. Okay, look at the crankshaft. The crankshaft has the main axis. Okay, this is main axis of the crankshaft, and it has an offset component. So we call this offset component crank. Okay, this crank is offset from the center. Okay, and the crank is connected to the connecting rod using bearing. Okay, so this connecting rod can rotate around the crank. Okay, like that, which means that, okay, during operations, okay, when piston move up and down, okay, the crank intake, okay, the crank is center here, but the shaft center is there. So there's offset between the crank and the crankshaft. So when it rotates, look at it, it rotates. The crank rotates in circle like that, and the center of the shaft. Okay, so it's moved here, and it's moved there, it's moved there. So it rotates around the center of the crankshaft. So that's how we get the rotation, the rotation motions of the engines. Okay. Now, okay, so the crankshaft, okay, we'll have the crank. Okay, in this picture, this is the crankshaft of a 4-cylinder engine. Okay, this is the first one, second one, third one, and fourth one. Okay, normally the second and third are on the same side. The one and fourth one, okay, the first and the fourth are on the other side, like that. Okay, so crankshaft, because it get power as a pulse from piston, okay, to complete one, let's say one round or two round. Okay, to complete one cycle is two round. Okay, down, up. Okay, two round. Okay, with two in two round there are four pulse. Okay, each cylinder has one pulse. Boom, 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 boom. So the power is not smooth. The power come as a pulse. It's like you hitting the crankshaft, hitting the crankshaft like that. Okay, therefore, if you use that power, it means that it's a power that has like come as a pulse. Okay, which we don't like. Therefore, on the crankshaft, okay, we install this flywheel. Okay, this flywheel serve, okay, as a driving member. Okay, so it's an output power of the engine go through this flywheel, and then the flywheel also act as inertia to damp out impulse caused by the power stroke. Okay, so there are two, let's say, two purpose of the flywheel. Okay, the first one is, okay, it has inertia, okay, large inertia, so that when you have a pulse, it doesn't affect the smoothness of the rotations. And two, it acts as a power output of the engine. Okay. Now, the intake, combustion power, and exhaust stroke, we already talked about it during the last lecture. Okay, in four-stroke engines for spark ignition, you have intake, okay, piston moving down and fuel coming in, okay, and then compress, okay, the pressure increase, the temperature increase, okay, both valves are closed, and then the spark plug generates spark, so fuel is burned and release energy, right? Release pressure and heat and push down the piston, and exhaust gas is pushed out during the exhaust stroke. Okay, so those are the four stroke. Okay, we already talked about the pistons. So okay, now we look at the valve. Okay, in engine we have two valves, at least two valves. The first one is the one that intake and fuel. Okay, the second one is the one that exhausts or let the exhaust gas flow out. Okay, so there are intake valve and exhaust valve. And look at it. Okay, during one cycle. Okay, one cycle means four stroke. During one cycle, the intake valve only open once, the exhaust valve open once. Okay, during other times, they are closed, right? So that's intake and exhaust valve. Okay, these are the two the pictures of the two valves. Okay, this is exhaust valve, this is intake valve. Okay, the valve has valve body and valve stem. Okay, valve body and valve stem, the same. Intake has valve body and valve stem. Okay, the main difference between the intake and exhaust valve is that intake valve is normally larger. Okay, it is larger because we need more area. Okay, we need more area because pressure difference during intake is smaller than the pressure difference between exhaust. Okay, during intake, okay, inside the cylinder is vacuum, outside it's just atmospheric, so the temperature difference is small. So we need more area so that the air can, I mean the air fuel mixture can flow in easily. Okay, but during exhaust, okay, the pressure difference is the pressure inside the cylinder, which is the pressure after the combustion. So it's high, pressure is high, and outside is atmosphere. So the pressure difference is large. We don't need a lot of area, so that's why exhaust valve is smaller. Okay, normally the valve when it close, okay, the valve is in the cylinder head, right? In the cylinder head. And when the valve is closed and it sit on this valve seat. Okay, this valve seat is part of the cylinder head. Okay, this cylinder head. Okay, and the stem is inserted into the a hole in the cylinder head also. So this valve guide, okay, is part of the cylinder head. So it's direct the movement of the valve. Okay, and this valve seat seal the combustion chamber. Okay, when valve is closed. Okay, so how the valves are open. Okay, so valve is open because we have this, let's say, valve train. Okay, we call it valve train. It is a mechanism that control the valve movement, the valve open and close. Okay, normally when you put the valve into the valve guide, okay, to put valve stem into the valve guide, this is, let's say it is intake valve. Okay, so this is and fuel mixture. This is cylinder head. This is valve body. So when you install the valve stem into the valve guide, okay, the other end of the valve stem, okay, the other end of the valve stem is connected to this retainer, and this retainer, okay, is pushed by this spring. So we first install the spring, and then we compress the spring, and then we put the retainer there, and we lock the retainer with the valve stem. Okay, so normally, okay, the spring push the valve stem up, which means that the spring close the valve. Okay, normally the spring close the valve. Okay, when we want to open the valve, we have to push the valve down against the spring. Okay, against the force of the spring. So we have this cam, okay, cam lobe on a camshaft. Okay, this cam lobe is not circle, right? It has like shape like that. Okay, normally when the nose of the cam lobe rotate down to the valve stem, it push the valve stem and it open the valve like that. So when the lobe move this way, right, the nose of the valve lobe kick the valve stem and open the valve. When it move away, okay, the spring push up and close the valve. Okay, so we open and close the valve using this cam lobe. Okay, and as we see earlier, we have many cylinder, right? So we have this cylinder there, and we have the one in the back, the one in the back, right? Okay, so we have many of these cam lobe, okay, and they are on the same shaft. We call it cam shaft. Okay, looks like this. Okay, this is a cam shaft. Okay, cylinder 1, cylinder 2, cylinder 3, cylinder 4. Right, it should be somewhere here, somewhere here. 1, 2, 3, 4. Okay, so those cam lobe control the intake valve and exhaust valve. So there must be one intake cam lobe for one cylinder, one cam lobe for exhaust valve of the same cylinders. Okay, so there's a cam lobe for intake, cam lobe for exhaust, intake, exhaust, intake, exhaust, like that. Okay, so this is called the toe of the cam lobe. This is called the heel. Okay, so that's camshaft. Now, the valve has to be operated synchronized with the piston, right? Because when the piston moving down during intake, intake valve has to open, so it must synchronize. Okay, it must work together. When the piston moving down, intake stroke opened, and when it's up, intake close. When power, intake close, and then with up again, exhaust valve open. So this has to work together. Okay, that's why we have to have a linkage between the camshaft and the crankshaft. Crankshaft tell you the position of the piston. Camshaft tell you the position of the valve. Okay, the crankshaft, okay, is tell you the position of the piston. Okay, so crankshaft and camshaft has to connect together. Okay, has to be connected, right? So when you connect the camshaft and crankshaft, you can connect by gear like that. Okay, this is camshaft gear. This is crankshaft gear. This is you can connect by chain. So you put one sprocket for camshaft on the camshaft. You want to put one sprocket on the crankshaft, and you put the chain on the sprocket. Okay, you can connect the two by belt. Okay, timing belt. We call it timing belt. Okay, the one sprocket on the crankshaft and one sprocket on the camshaft. Okay. Now, when you connect the two, you want to control the position of the valve and the piston, right? Therefore, when you connect, you cannot allow any slip between the two sprockets. Okay, the gear is good, okay, to prevent slipping. The chain is good to prevent slipping. Okay, the benefit of the chain is that the crankshaft and the camshaft can be further away. Okay, it can be further away. If you use gear, it has to be close. They have to be close together. Okay, if you use chain, they can be a little bit far away. Okay, if you use belt, you cannot use just a typical belt. You have to use belt with teeth. Okay, teeth. We call this timing belt. Okay, the belt with teeth. Okay, or the teeth with the sprocket with teeth also, right? If you use belt, okay, you have can let the two sprocket a little bit more further away, right? However, you have to control the tension of the belt. Okay, so these are the three ways you can connect crankshaft and camshaft. Okay, now if you look at the gear and sprocket, you can see that there are size different. Okay, there are size difference between the two. Okay, that's because during one cycle of like four-stroke engine, the crankshaft rotates twice. Okay, in one cycle, okay, crankshaft, okay, the one under rotates twice, so two round until it finishes one cycle. But the camshaft only operate one round because it's open the valve only once, right? So two round of crankshaft must be equal to one round of camshaft. That's why the camshaft sprocket has to be twice the size as the crankshaft sprocket always. Okay, because to complete one cycle, okay, this one rotate twice, this one rotate only one. Okay, one round. Now there are many valve arrangement. Okay, you can have valve like this. So the intake come in, go up, reverse, and go to the cylinder like that. We call that L head or flat head. So this cylinder this engine has flat head. Okay, you can also have camshaft in engine block. Okay, down here is engine block, up here is engine head. Okay, you can have camshaft in the block and connect the camshaft to the valve on the top, right? You can have overhead camshaft, okay, with only one camshaft, where this camshaft have to serve intake and exhaust, right? Just like this one. Okay, we call it single overhead camshaft. Okay, we also have double overhead camshaft. Okay, and that's one camshaft for intake valves, the other camshaft for exhaust valve. So we call it double overhead. Okay, it's up camshaft. Okay, this is a valve train for V-type engine. Okay, some engine has V-type, which means one cylinder move like this, one a couple of cylinder move like this, a couple of cylinder move like this. Right, so it's V shape. Okay, you can also design the camshaft. Okay, one camshaft and control the two banks. Okay, the V engine. Okay, we're gonna talk more about this one and that one. Okay, basically this one. But this one is basically original popular valve train for engines. Okay, but it's already outdated. Okay, now most engine, actually all engine now use overhead camshaft like that. Okay, because it can control the valve a lot more precise, a lot quicker than this type. Okay, but let's look at this camshaft in block. Okay, so sometimes we call that only overhead valve. Valve is overhead, but camshaft is still in the block. Okay, camshaft is there. Okay, the valve is there on the top. Okay, so how it works? Okay, in this system, okay, you have camshaft, you have cam lobe. This cam lobe push this valve lifter. Okay, this valve lifter, this one. Okay, valve lifter function is that to make this push rod sit on the cam lobe. Okay, so this function is connect between the push rod and the cam lobe and make the push rod sit on the cam lobe, right? So this guy sit on the cam lobe and then connect to the push rod. And we have push rod. Okay, when the lifter push up, it push the push rod, it push this rocker arm. Okay, the pivot point is in the middle. Okay, in this middle here. So if you put this side up, this side go down to open the valve, right? Okay, if the cam lobe, okay, the toe of the cam lobe pass away, okay, pass out, okay, move away, okay, move away from the lifter, okay, the spring push the valve, okay, close the valve, and then push the rocker arm push down like that, okay. So this is overhead valve. But there are also some Thai word for that, okay. Um, the piston is look soup, okay. The cylinder wall or the cylinder is kabok soup, okay. The valve, okay, some technician, Thai technician call lin, okay. The cam or the cam lobe, Thai technician also called plow lao lin, okay. plow lao lin นะครับหรือว่า cam shaft, okay, sometimes they call cam shaft, okay. This push rod is called ตะเกียบ, okay. Spring is called spring. Rocker arm is called กระเดื่อง okay, in Thai. Okay, so there's like cam shaft. Okay, this one is called, I think, ลูกถ้วย okay. ดันลูกถ้วยดันตะเกียบ okay, ตะเกียบ push กระเดื่อง okay, กระเดื่อง push ก้านวาล์ว okay, valve stem is ก้านวาล์ว okay, and เปิดวาล์วใช่ไหม okay, so that's the overhead valve. Now the how you say, the drawback of this type is that it has many components, and this component is not really rigid, okay. It can flex, okay. It is flexible, a little bit flexible. It's not like theoretically rigid, right? Which means that, okay, when you push the push rod up, instead of the push rod pushing the rocker arm, okay, it flex a little bit, okay, and then after it's flex, it push the rocker arm, which means that, okay, when you want to control the opening of the valve, okay, it's how do is that there is some delay, okay, there's some delay between the camshaft and the valve, okay, and this valve is open very fast, okay, it's open every cycle, it's open like, I don't know, 2000 times per minute, okay, 2000 times per minute is quick, okay. We cannot allow any delay, okay. This one has delay between that, okay, and there are some clearance between this part and this part, some clearance between this part, some gap between this part and this part, that can slow down the opening or affect the precision of opening the valve opening. Therefore, okay, for new engines, okay, we try to remove the component or the parts of the valve train, and we use this overhead camshaft, okay, overhead camshaft. Okay, this overhead camshaft, they have like cam lobes, and the cam lobe push down on this bucket. Okay, now we call it bucket tappet, the same thing. Okay, in Thai we call ลูกถ้วย okay. We push the bucket tappet and then we push valve stem, so we have less component, we have less delay, less flexibility, like less flexible components, okay, and we can open the valve quicker, we can open, like, the opening can be more precise, okay, the precision is better, okay. So this overhead camshaft is used nowadays, so it eliminates lag produced by the push rod and the rocker arm, okay. Now the minimum valves per cylinder is one intake and one exhaust. However, for new engine, okay, they not only put only one intake and one exhaust, okay. Normally they put more than one, two intake, two exhaust, okay, or two intake, one exhaust, right. You put more valve, we call this type of engines multi-valve, okay. All modern engine has multi-valve, okay, because when you have more valves, you can increase the area, okay, increase the floor area, okay, or floor cross sectional area, and then okay you can help improve breathing and increase, okay, when you help improve breathing, which means that you provide more area, okay, engine need less power to suck in the air, right, because you open a lot, right, you have a lot of opening, right, it use less power to intake the air, which means engine can produce more power because it use less here, okay, it can give back and it can use it to drive the car, right, so that increase power output, okay, which means basically if we talk about efficiency, it improves the volumetric efficiency, okay, and volumetric efficiency is efficiency that consider the intake and exhaust, and valve diameter is smaller and it weight less, okay, when the valve weight less it move faster, right, okay, when the weight is lower the inertia is lower, therefore the acceleration is more, right, summation of force equal ma, okay, if m is less you can have a lot of acceleration, which means that it move fast, okay, so we want valve that is move fast, okay, so we want light valve like that, okay, therefore now we have two for intake and two for exhaust. Now, so that's four stroke engine, okay, four stroke spark ignition engine. Okay, now let's talk about other engines for a little bit. Okay, we're not gonna go much into detail after this. Okay, we're gonna talk about its operation. Okay, these different types of engines a little bit here. Okay, let's first start with two-stroke engine. Okay, the two-stroke engine in two-stroke engines. Okay, the whole cycle is completed in two-stroke. So down and up, finish, down and up, finish. Okay, not like four stroke, down, up, finish, right? So this one is just down and up. So the construction or the design of the engine are quite different. Okay, the common two-stroke engine, okay, has three ports. Okay, it's not valves, it's port. Okay, it's not valve. Okay, so there's intake port here. So take in the air and fuel mixture, admit air and fuel mixture. Okay, the transfer port here connect between the crankcase. Okay, so the room that has crankshaft is called crankcase, and then the cylinder or the combustion chamber, and then exhaust port. Okay, so the design is quite different. Okay, let's see how it complete the cycle in only two strokes. Okay, so what happened is during upstroke, okay, when the piston move past the intake port, okay, normally when it move up, it create vacuum inside the crankcase. Okay, this vacuum is created inside the crankcase. Okay, when it move past the intake port, okay, the air fuel mixture is like sucked in, okay, because of the vacuum inside. So the air fuel mixture move or flow into the crankcase. Okay, at the same time, okay, the things, okay, the air fuel, okay, on top of the piston is compressed. Okay, so it do the two things at the same time. So it intake into the crankcase and it compress air fuel mixture at the same time. Then when the piston move to the top, okay, we ignite the air fuel mixture and it burns, it push down the piston. Now it push down the piston and we get power. Okay, as soon as the piston move past the exhaust port, okay, the pressure inside combustion chamber push the exhaust gas out like that. Okay, just when it passed the exhaust port, it pushed the exhaust gas out. At the same time, when the piston moved down, it compressed this air and fuel mixture. So it push the air fuel mixture, and then the mixture flow in the transfer port to the combustion chamber, to the cylinder, okay, to the cylinder. So it's just like exhaust going out, and after that a little bit intake coming in, and then the piston move up again. Okay, so it's like during one stroke it do many things. Okay, and it also use crankcase to store the the air fuel mixture. Okay, the intake, the the the, the air fuel mixture coming in. Okay, therefore, okay, normally when we use the two-stroke engine, okay, we still use it for like in the farm, okay, in the plantations, okay, in agriculturals, okay, we still have small engine that use two-stroke, okay, but it's like it's is more outdated, okay, because when you use two-stroke, okay, the first thing is that you have to put some lubricating oil in your fuel tank, because that oil has to lubricate. Okay, we have to put oil to lubricate the crankshaft, right? Because air, I mean, fuel and air goes into the crankshaft, so we have to put lubricating oil there. The other thing is that we cannot really control the amount of air fuel and the ratio of air fuel, okay, and the timing and the combustion time. Okay, we cannot control that very precise. Therefore, this engine cannot generate complete combustions, which means that, okay, it lost a lot of fuel. Some fuel do not burn. Okay, some fuel does not burn. Okay, so you lost that fuel. Okay, so it have bad fuel economy. It also have bad emissions. It create a lot of pollutions. Okay, so that's why it's not very popular now. Okay, so that's two-stroke cycle, two-stroke engines. Okay, let's talk a little bit about diesel engine. Okay, in diesel engines, only air is intake into the into the cylinder during the intake stroke, and only air is compressed, so there's no fuel. However, for diesel engine, okay, we compress more. Normally for gasoline engine we compress 8 to 1, right? For diesel engine you compress like 17 to 1, right? 20 to 1, so you compress more. Okay, when you compress more, the air is has high pressure and also has high temperatures, a lot higher temperatures than benzene or than gasoline. Okay, now you have hot air inside. Okay, when you want to start combustions, you have to you just have to inject diesel. Okay, when you inject diesel, it burns right away, right? It burns right away. But it depends on how good you inject that fuel. Okay, how small droplet you can make. Okay, if you can make a small droplet of fuel, okay, you can spray in a small droplet, it can burn very good. Okay, but if you cannot spray the droplet, okay, if you spray inside, just like spraying, okay, uh, some diesel do not burn. Okay, that's why diesel has more smoke than benzene, okay, than gasoline. So as soon as you inject diesel, it burns, and then the rest is the same, right? Power and exhaust stroke are the same. So this is diesel engine. Okay, the temperature before the diesel injection, okay, we call injection. Before diesel injection is more than 600 C. Okay, it's hot enough to do that. Okay, that's why modern diesel engines is compete, okay, by increasing the pressure of the diesel fuel. If you can increase, let's say here, if you can increase the pressure of diesel, okay, you can inject, you can spray the diesel, okay, such that it has very small droplet, okay, and then it can burn very good, and you get more power. You get, I mean, You get better fuel economy, a lot of things. Okay, now the last type of engine is rotary. Okay, we talk on the first slide. Okay, on the first slide at the beginning of this lecture that engine has two types. The first type is reciprocating, which we already talked about. The second one is rotary engine, okay, which is this one. Okay, the rotary engines. Okay, this rotary engine is called Wankel engine. Okay, this is a guy who developed, okay, who create this rotary engines. Okay, therefore we use Wankel engine or rotary engines. It has rotors inside. This is rotor. It's like triangle rotors inside the oval chamber. This is a chamber. Right, this chamber looks like the number 8. Okay, so it's larger here and smaller here and larger there. Okay, that's the chamber. This rotor move inside this chamber, and they have intake port and they have exhaust port, just like the two-stroke engine. Okay, when the rotor rotates, okay, it rotates this shaft. Okay, and this is the output shaft of the engine. Okay, the main shaft of the engine. So when you read this picture, okay, read this one first. Okay, 1 to 4 are intake part, 5 to 7 are compressions, 8 to 10 are power, and 11 to 1 are exhaust steps. Okay, so look at this volume. As the rotor rotates, this volume is larger. When you create larger volume, you create less pressure, right? So it creates vacuum. Okay, so as the rotor passes through this, it suck in the intake. Okay, suck in air fuel mixture. So air fuel mixture coming in 2. Okay, 3 is larger, so it keep coming in. 4 is larger, so it keep coming in. So 1, 2, 3, 4 are intake. Okay, now the rotor close the port, right? And then 5 is closed and 5 is smaller, so it compress. It start to compress the air fuel mixture. 6 compress into the smaller volume. 7 very small. Now you ignite air fuel mixture. Okay, inside here is compressed air fuel mixture. So after you ignite, okay, the mixture is burned and it push the rotor. Okay, it expand and it push the rotor. Okay, now 8, so it's larger, expand more to 9, expand more to 10. Okay, here are the power stroke. Okay, you push the rotor, and then when it passes the exhaust port, it start exhaust steps. Exhaust 11, small 12, and it goes to 1. That complete the cycle of rotary engines. Okay, which means that when it rotate, okay, one round, okay, one round like that, it can combust 3 times because there are 3 volumes, right? There are 3 volumes, so it can ignite air fuel 3 times. It can combust 3 times. That is why rotary engine has a lot of power, and it's fast. Okay, the speed is fast, and it has a lot of power because one round it spark like 3 times. Okay, it combusts 3 times. There are 3 power pulse. Okay, it's not only that. In typical rotary engines, okay, they have 2 rotors, which means that one round, okay, it has power pulse of 6. Okay, it has 6 power pulse because it has 2 rotors. Okay, so that's why it has a lot of power. Okay, but it has the same drawback as the two-stroke engine. Okay, you cannot control the amount of air fuel. You cannot control the combustions very good. So you use a lot of fuel and you create a lot of pollution with this engine. Okay, so this engine, okay, Mazda company have patent on the rotary engine. So therefore the only rotary engines in cars that you can see is in the Mazda engine, right? It's Mazda Sport engine. Okay, RX-7, RX-8 use rotary engine. It is small car, but it's very fast. Okay, so that's rotary engine. So that's the last slide. Okay, so that's about it for the second chapter about engine operations. We talk more detail about four-stroke SI engines. Okay, we cover two-stroke, we cover diesel, and we cover rotary engines. Okay, so that's it for today. Okay, bye bye.